Hello, everyone. Thank you for joining us for our Beyond the Plate, the Future of AI LPR in Smart Parking and Enforcement webinar. I'm Alex Bourne, the Marketing and Communications Specialist for Precise ParkLink. Joining us today is Cynthia Bruce, who's our Associate Director, Proposal Development. Cynthia has a keen ability to identify client needs and craft winning strategies. She collaborates with subject matter experts and aligns marketing and proposal messaging. Alongside Cynthia, we have Jay Benzel, who is one of our system engineers. Jay develops and tests the technology behind our automated access and revenue control system. He plays a key role in integrating LPR, parking guidance, and more to enhance client operations. So during today's webinar, you'll be taken through the following: license plate recognition in the Canadian market today, the basics of AI-based LPR, why AI-based LPR is a popular interest among all markets, unlimited possibilities with AI-based LPR, getting to know transient AI-based LPR parking models, hardware and software considerations, future improvements. To wrap things up, we'll end it off with a Q&A. If you have any questions throughout the webinar, please leave them in the chat bot and we'll answer them during this time. Also, make sure that your message is set to either me, Alex, or everyone, so we can see them and answer them. To get us started, I'll pass things off to Cynthia.
Great. Thank you very much, Alex. We look forward to some great questions. We have a fantastic crowd here today. And I am pleased to be giving my second participating in a second webinar on LPR. And since the last time I gave it, there's been some new things come about. So there's actually some new stuff to talk about. So if we have any repeat customers, you may see some duplicated content. There's a lot of new stuff, so bear with us. So I'm just going to start today with a quick update, and we're going to get through all of this pretty quickly. So everybody here, I'm hoping knows by now, LPR is license plate recognition. And what we've really been seeing is that there's been a trend towards embracing this kind of technology. It's expected to experience more change than any other technology in the parking industry so far. And we're talking about the longevity of your investment. And we're talking about reducing that capital expenditure or that CapEx. And by embracing technology that can do more with significantly less. So over the years, our clients and their customers have been demonstrating that they want an easier experience. They want parking basically to be a non-event. They want to come in, they want to come out, they want to go about doing their business in between, and they want kind of the parking on either end of that to just be part of the thing. They don't want it to be a big brouhaha. They certainly don't want any problems. So if our goal is making it a non-event, it's really about aligning technology and processes to help that happen. And our sites owners and our clients, aside from obviously wanting to make their customers happy, they want more security. They want to have more accuracy when they're doing their enforcement. They want to reduce the amount of time where people are trying to dispute parking tickets or just the number of disputes that they're receiving. They want to secure their revenue, and they want to make sure that people are paying for the assets that they're borrowing, which is the parking stalls that we offer them. And the more accurate we're able to get with the technology that we're offering, the more voluntary compliance we're going to see, especially in those non-gated parking lots, which is going to lead to more business intelligence, higher revenues, and we can offer this to our clients with license plate recognition. So next few slides, we're just going to talk about some of the areas where license plate recognition is doing something today. And these are all areas that we're familiar with, right? So we've got the speed limit cameras. I think everybody by now, especially in Southern Ontario, we've seen them showing up in our neighborhoods in those lovely gray boxes that everyone loves to tip over. So these camera-based speed enforcement cameras, we're starting to see them all over. So we have on the toll-based highways, again in Southern Ontario, and all over. I'm sure you've heard of our wonderful 407 ETR toll highway. They have them in the United States as well and throughout Europe, where they're really leveraging the power behind LPR cameras to handle the monitoring and the usage and the billing associated with the use of those toll highways. We are also seeing this when it comes to enforcing our parking sessions. So everybody has probably at some point in time seen, and it's in the background picture here, a car with those big cameras on top and they're driving through parking lots. Well, with the advances in the technology, our R&D team actually has come up with something that's really cool. And instead of having these big clunky cameras that are costing almost hundreds of thousands of dollars per vehicle to set up, our team has actually been able to harness the power of that and using cell phones and tablets stuck into the windows of cars as they're driving by the aisles. So, it might sound a little bit like, not quite, but it's not the device that's important here, right? It's the power of the software in the engine that drives it. So if we can reduce, again, our capital expenditures, but still get all the power and the use out of the software, that's where the power is going to be. We're also seeing it with obviously managing parking access controls. If we think about Toronto Pearson, they're using it there. We have some other clients as well that are using the LPR to enhance their parking access or their permit control game, if you will. So LPR, what it really allows us to do is provide a comprehensive solution. And with that, we're really talking about who is using it and how are they using it. And traditionally, it's just been the really, really big clients, the Toronto Pearsons and the Montreal airports of the world. But as the cost of the technology is coming down and as the power of the data analytics and the now, adding on the enhancements of AI to it, it's really become an affordable solution. And the data that it's providing and the business decisions that it's enabling is helping clients in all sectors really leverage this and helping them make smarter decisions. So it's not just the airports anymore, right? That we're talking about universities and colleges are absolutely getting in with that. Commercial clients, we have a couple premier commercial clients in Ontario and Alberta and BC who have embraced this wholeheartedly. And it's not limited to that because municipalities are also using it. Now, they've been using it for a long time with enforcement, perhaps, but now they're seeing the power of using that in more traditional parking operations. So we want to talk about some of those opportunities a little bit here. So as we touched on earlier, we're going to have more accurate enforcement. We are going to have the ability to offer occupancy and inventory tracking. And that's actually something our R&D team has been working with a high-profile client on. And being able to track inventory in a parking lot, like that's been a huge deal. Nobody's really, I don't know if they haven't worked on it or haven't figured it out, so I won't say which one it is, but our team did. So, and LPR is what enabled that. Frictionless parking, we've been talking about this as an industry for years. I've been in the parking industry for coming on to 10 years, and, the last 8, certainly. It's part of the lexicon right now. So LPR is really moving us into a whole new stratosphere when it comes to being able to offer frictionless parking. Hands-free reservation, that's just going to be part of that frictionless parking experience. And as the reservations and the validation. So really about using the power behind having a license plate as a credential to power all of these services. The business intelligence, we could have an entire webinar that's dedicated strictly to that. So we won't expand on it too long, but I'm sure you can imagine how much more, and we'll talk about it a little bit more, and Jay's going to talk about it. And that'll be the more interesting part for sure, about what kind of metrics we can extract and what we can do with those. Dynamic pricing, we're going to touch on that a little bit more, so I don't want to talk about it right here. And then when we start thinking and expanding, where can this go, other revenue streams that this can generate, and other ways that we can really enhance the Parker experience, we're talking about marketing and loyalty programs. So there's the business side of that, and there's that Parker experience side of that as well. So when we're talking about opportunities, we also want to make sure that we cover off efficiencies, right? LPR is going to offer so many efficiencies, and the market at whole across North America is catching on, right? There's an interest in all markets. It's no longer being relegated to the high dollar locations because it's no longer a high dollar technology. And we're seeing requests across our company and across some of our competitors. We all have these conversations, and we're seeing these conversations happen everywhere. They're just in casual conversations. I just talked with it about my chiropractor before starting this webinar. He just kind of brought it up. So, we talked about it a little bit. We're seeing it when clients are asking for quotes and proposals that talk about it and explain what's going on. And we're starting to really see it hit in the procurement side of the business through RFPs and RFIs that are hitting. Our team sees that every day almost now. So when we talk about who we're benefiting, and I say, all the sectors, all the verticals, all the clients, I really wanted to take a moment here to touch on who those are. So we're talking about airports, we're talking about hospitals, we're talking about hotels, mixed use developments like the Well, for instance, here in Toronto is the one that comes to mind because I was just there over the weekend. So really, there's no limit to who can benefit from LPR in some capacity. So we're going to expand a little bit now about the possibilities and what we can do with LPR, right? So there's the traditional things, lists. We have access lists, we have lists where we're blocking people, and we have lists that are going to generate, or notifications, lists that are going to generate notifications. There we go. So access lists. So we're talking about, your traditional permit parking type of thing, or you have a VIP coming in. LPR is going to help us do that and manage those. Again, not having to worry about physical credentials is really where the power here lies in this, in your traditional access control process. And then when we're talking about blocking lists, not necessarily for all kinds of sites, but we're talking about restricted lists, or if we have vehicles of interest, we want to be able to kind of see who those are. And we're also seeing that there's some popularity here about locations that have these high-speed roll-up doors. And then on the notification side, and this is where the vehicle of interest kind of crosses over, right? So we have the BOLOs, we have those vehicle of interests. In some locations, there's connections with enforcement and with police services. So that's where the BOLO would come in to be on the lookout. I apologize. And then when we're talking about enforcement notifications, we're going to talk about that a little bit later. Just a couple more slides, so bear with me. And this is actually one of the most interesting pieces that I think that we can do with LPR now. So just to start getting into it, why does it matter to use LPR when we're talking about enforcement? So obviously we're talking about non-gated lots, and it could be that it's has a multi-space meter, or it has a mobile payment, or it can have both, or it can have one or the other. It has to have something, right, to process parking sessions. So so picture this: you're coming into a gated lot, there's going to be a camera there, and it's going to capture a picture of your license plate as you're coming in, and it's going to capture one as you're coming out. So what this is doing is that it's increasing the accuracy of enforcement, because we know exactly when people are coming in and when they're coming out. And this allows us, on behalf of our clients and our clients, to really implement some business rules that focus on the accuracy rather than historical rules or historical volumes or historical trends. So we're going to go on to the next slide, please. So what's happening here is that when that license plate is captured upon entry, the system is going to check to see, is there a parking session associated with this license plate? So it's going to check to see if there's a permit, or check to see if there's a reservation or a parking session that has been prepaid. And let's say none of those things come up. So the system's going to say, no problem. They're going to give 15 minutes, 20 minutes. That's a time frame that's obviously configurable, like just about anything in parking. And then it's going to check the system again. And if it still doesn't register a valid parking session by whatever means is accepted within any individual operation or site, it will then send an alert to our dashboard, our operational dashboard called Park Suite. And it will say, oh, hey, we have someone here who hasn't paid. It's been 15 minutes. And now we have some business decisions that are going to come into play. And over time, these business decisions will be informed by these data-driven metrics. So at first we could say, well, I've got 400 stalls and I don't want to send someone out on a patrol to find this car to give out one ticket. But when there's 10, that's when I want to send somebody. And so now we can have reactive patrolling and enforcement when we have a higher certainty of locating those vehicles. And over time, what happens is, as you saw on the previous slide, is that we're going to see a decline in disputes because, one, obviously we have proof, but two, your parkers are going to learn that, you know what, this isn't, I can't just take my chances with a voluntary or compliant payment anymore, because now they know when I'm here and they know if I've made my payment. If I don't make my payment, I'm going to get a ticket. So it's no longer worth it to kind of try and run the risk or run the odds about, well, paying or not paying. Is a patroller going to hit, not going to hit? Because our parkers get savvy to, oh, they only come once a day. They only come twice a day. Or, they come every hour on the hour, and they can kind of game the system a little bit. Well, this eliminates that almost completely. So there's many ways that we can help with that. So we're going to have those cameras on entry and exit, and then we're going to add them to those enforcement vehicles. So it just makes the patroller's job that much easier in locating those vehicles. And it can be put on the car, as I described earlier. It can just be on a cell phone or on a tablet if your patroller's going by foot, or if they're perhaps in a golf cart in some locations like they do in Vancouver because it's so nice there all the time. And, that's different ways that they can go ahead and do that. Now, the next slide, this is super interesting. Again, could be a whole other presentation. So we are just going to talk about these things. If you want more information, please let us know. We'll respond to you in the chat, or we'll have someone reach out to you with some information. So camera-based parking guidance systems. I'm sure everybody's heard of them at the very least. You've seen them somewhere, I hope. If not, you're seeing them here. They're very cool and super fantastic. And if you can geek out about parking, this is a great thing to geek out about. So you go into a parking garage, they have these sensors that light up, and if it's red, well, there's no parking in those 4 or 6 stalls, and if it's green, well, there's at least one parking stall open in those 4 or 6 stalls. So that makes it easy for us to find parking. So it reduces the amount of congestion in lane and driving around, and safety for pedestrians, all that fun stuff. But when we're talking about LPR, these sensors have the camera in them. The camera is capable of capturing the license plate. It runs through all of the OCR and the LPR software. And what it does is it records the vehicle in a specific stall. And then when you're coming back from your 2-week trip to Mexico and you have no idea where you parked because you didn't take a picture of where you were or you didn't write it down, when you're paying for your parking, you can just type in your license plate at the pay station or at a kiosk, depending on how the site is configured, and it'll tell you exactly where your car is parked. And it's actually going to give you a map on how to get there. So that is a pretty cool experience. You can test that out at Toronto Pearson if you wanted to, just for the fun of it. And additionally, for site owners, there is a security module that is attached, and we're talking about like security guard security. It's not what we do, obviously, but that is available to clients if they wanted it. Okay, so dynamic pricing. So this is another really cool functionality that LPR has enabled for us because we're getting those really rich data and metrics. We're able to do all kinds of analysis with that, and it can be past-based analysis, and it can also be future-based analysis, and it's going to allow us to kind of guess at what's coming next, but it's all based on data, right? So dynamic pricing. So this is going to allow us to set pricing strategies that fluctuate based on various parameters. So it can be based on the time of day, it can be based on a date, or it can be based on the time of the year. So if you're a hockey arena and it's the playoffs, that time of the year might be a little bit more expensive to park at than, in July. We have the technology now that's pairing with the LPR that's going to allow us to do occupancy-based pricing as well. So based on the volume of vehicles in your parking lot, it can trigger some preset rules to increase or decrease your parking rate at that time. So it's not tied to the time of day, but rather to occupancy. We can also set dynamic pricing based on the type of customer that we have, and that can be derived from a variety of different methods, like looking at the model of a car, for instance, or like at Pearson, again, at a parking stall location. This is something we talked about. I'll be honest, I don't know if it was deployed, but we talked about the possibility of, or the power rather, of saying that, well, if you're going to park right next to the elevator, that parking stall is going to cost you a little bit extra money. Or if you're going to park over here and this is like a donation zone because we're supporting a charity this month, that extra money is going to be a donation to the charity. So a lot of really cool things that we can do when we have LPR within our parking facilities. So business intelligence and data collection, this is probably what is going to interest most business owners. So we've always known when cars are coming in and when they're coming out. And we can tie it to a ticket number in a gated lot. And we can tie it to a transaction in an ungated lot. We can now tie it to a license plate in the mobile payments or the pay by license plate lots. But now with the LPR, now we're tying that activity specifically to a license plate. And now that becomes our identifier. That allows us to track repeat parkers, how, depending on how the parking lot is set up, where they're parking, how long they're parking for, when are they coming, are they parking in a high demand area, or are they parking up on the roof at the very top and they don't mind the walk? So by looking at these metrics, we're now able to make some business decisions based on, when we want to change our pricing, when we want to offer some programs. And we can use these and we can extend it to promotional offers through a marketing campaign. We can create a whole loyalty program about that. We can adjust the rates and the offers to our repeat parkers. Maybe we want to give them a discount because they park here all the time. And then, when we start thinking and expanding about technologies and alternate revenue streams that are derived from our parking activities or the parking sessions that we offer, pairing that with geotagging and enhancing the revenue generation by saying, hey, we're going to say you're here and you park here a lot, and we're going to offer you a discount over there. So now you have a partnership with a neighboring business or a merchant, and there's a potential there for some revenue sharing between the two businesses as well. So lots of cool opportunities. I'd say the sky or your imagination is the limit as to what you can do with LPR.
Thank you, Cynthia, for that comprehensive look at LPR. I'm now going to pass it over to Jay. We'll take a deeper dive into AI-based LPR.
Thank you. So now we're going to explore some basics of how AI LPR, AI-based LPR works and how it ties into the parking side of things. So really at the core of it, LPR primarily ties into parking systems by replacing your traditional credential system, such as tickets or passes, with your license plate. And what that enables is it opens a door to a lot of future possibilities. Now, this works for all different types of parking systems. Cynthia touched on that briefly, but you have gated lots, and LPR can be used for reconciliation, especially for long-term parkers for their lost tickets. So if they lost their ticket, you know exactly when they came in, and you can charge an appropriate amount to that. You can also use it as a credential for staff to conveniently allow in and out access to staff lots. And that's especially useful in the wintertime when nobody really wants to roll down their window to tap a badge, etc. And then for the non-gated lots, LPR can be used in conjunction with metered systems or mobile app-based virtual parking systems. And what this enables is license plate enforcement, which was discussed with Cynthia earlier. So now we can jump into how the core of the technology of the AI-based LPR works. And really what it comes down to is, and how it differs from traditional LPR systems, is the use of deep learning models and computer vision technology to identify vehicle license plates. And what this enables is a unique pattern recognition characteristics that allow high accuracy while also being able to adapt to a variety of challenging and environmental conditions. And it also supports a wide variety of license plate formats. Now, when you talk about AI, it's a very generic term, but specifically when we're talking about AI-based LPR, we're talking about the computer vision applications of AI. And under that computer vision application of AI, you have technologies like object detection and optical character recognition, also known as OCR, which are sitting as key applications as part of the computer vision. As a subset of the AI, you have machine learning, and specifically supervised machine learning, where the training data is labeled and annotated, is used to build, deploy, and train these models. And the models are specifically using deep learning, where the models are trained using artificial neural networks, that's also known as deep neural networks, to train on a large amount of annotated data. And what this does is a biomimicry, which mimics the human brain, and using multiple layers of neurons to extract key features automatically and find key patterns to recognize the objects and to conduct the OCR. And then in terms of the inference, these models are based on a one-stage detector, which really minimizes the inference time, and also minimizes the compute required for these models to run. So to go into more detail about the differences between the newer LPR compared to the traditional LPR, really what it comes down to is the AI-based LPR is more adaptable. It also works with non-standard plates. So typically the standard LPR that you would have in the past would be ideal for European or British plates, but now we can handle all sorts of plates. And ultimately it works with higher accuracy, which is the most important metric for a given LPR system. And then today, what we're seeing in the real world, it's not really uncommon to see LPR accuracies of well above 95%. And in some areas, we've seen 9 or even 100% accuracy over hundreds of plates, which is really useful. So for a high level architecture overview of the system, really what it comes down to are three components. You have the LPR module, which is a multi-stage detector application that identifies and tracks vehicles from a live camera feed. And this is what uses the advanced OCR technology that I'll get into a little bit more to accurately extract the license plate information. Next, you have the events that are sent to a centralized database that holds all of these detected events, and it's used to do all the business intelligence for auditing and for analysis. And all of these events can also be synchronized through a secure API to a third-party system for further integrations. Now, to break down the LPR module of the engine into more detail, we have the following 6 steps. So really, where everything starts off is a capture of the license plate. That typically happens through IP-based cameras. Normally, we run on a camera running 12 to 30 frames per second, depending on the expected speed of the vehicles. These cameras are typically running 1 to 2 megapixel resolutions, which we find is enough to detect the license plate accuracy. And what is really capturing here is looking for key objects such as vehicles or license plates, and it's looking at that multiple times a second. Next, once a key vehicle or license plate is detected, the object is tracked to the frame of the actual field of view of the camera. Now, this does 2 things. One, it determines the direction of the vehicle. So in some locations, we have one camera and it's detecting vehicles going in both directions, and it's able to differentiate based on the how the object moves throughout the field of view of the camera. Also, what we typically do is we define a specific region of interest where we want to ideally capture the license plate. And what that does is enables the high amount of accuracy as well as minimizing the inference time of the event. Next, once the object is is located in a specific region, we specify the license plate and we send it to the next step where the cropping of the license plate is conducted in the full field of view of the camera, as well as any skews or tilts are corrected for. That's kind of called perspective correction. Once we have the crop out of the license plate, we actually run the optical character recognition, OCR engine, and that really takes in multiple frames of the license plate and keeps analyzing it until it's satisfied and has the confidence threshold to send that license plate off to the next step, which is post-processing. So once we have the OCR results, sometimes we have multiple cameras in one lane. So you have a front camera and a back camera, and these events are combined to give you more confidence that it is indeed the plate that are read. It also looks at a list of known plates and says, hey, if this license plate is one character off to a list of known plates, most likely it is that plate, and then uses that to do a fuzzy matching and allows the vehicle to access the system. The other thing that it does is we look at the character sequence. So based on a certain jurisdiction, for example, in Ontario, most of our plates are A, B, C, D, 1, 2, 3. So if there's a character sequence and there's a likelihood of one or two misreads, we can also correct for that to increase the accuracy even further. Finally, all of these results and associated metadata, such as the color of the vehicle, the type of the vehicle, and the make of the vehicle, is sent over to a centralized database where we do the business intelligence, and we really do some further calculations to calculate dwell time, etc. Now, there are two types of AI model training that I'm going to mention here. We do continual improvement training. So that involves collecting a license plate data from a variety of sites and running that through the machine learning model to train on millions of license plates to increase the accuracy even further. And that typically happens every 3 to 4 months. It's a fast moving field and we see the accuracy improve year over year. And then secondly, there's also site-specific training. So if we deploy a LPR system to a specific site, and for whatever reason, based on the jurisdiction or other factors, we notice that the license plate accuracy is not up to par. For example, if the H's are being constantly misread as B's or the other way around, we take and collect images specifically from that site and do a custom training on that site to improve the accuracy and get it up to what we expect it to be. Now that we have a better understanding of how AI-based LPR works and how the models are trained, we can also recap some of the main benefits, which include higher accuracy. And this is a higher accuracy in a variety of conditions, which we'll see some real life examples soon. There's also very fast processing time. So you get the events in real time. You don't have to have the person sit and wait for a long time on the gate. You have adaptability to different jurisdictions. So it handles all sorts of plates in all provinces. You also have improvements in computation and power that have enabled the technology to be quite cost efficient now. And the system is generally quite scalable. So if you have more lanes to add in the future, that's not a problem typically. Now we're going to go through some impressive reads from the AI-based LPR system that kind of highlight the power of the system. And you can see here that we have a license plate where the vehicle is driving in dark conditions. That's why you see everything in black and white, because the camera is capturing everything in a IR environment. But even with these challenging conditions, and there's snow on the ground, there's snow, it's actively snowing, and the license plate also has a little bit of dirt on it. Even regardless of all of these conditions, it's able to see through and detect the license plate, albeit at a slightly lower accuracy than what we, slightly lower confidence, sorry, than what we typically expect, but it's good enough nonetheless. So the next slide that we have here is an example of a truck. And if you look closely, there's actually a chain hanging in front of the license plate. But regardless of these kind of small obstructions, the AI system is able to pick out unique characteristics of the characters in the license plate and is able to do a successful read. The next example we have here is actually a delivery vehicle, and you can see there's a lot of other text on the vehicle, but it ignores all of that and it focuses on the license plate itself, and it runs the OCR on the license plate to get a successful read. And the next slide is actually particularly interesting because you can see that the bottom of the license plate is actually cut off. This is due to the vehicle following this is due to one vehicle following another very closely. But even with the bottom of the license plate cut off, it's able to extract unique characteristics of each character and able to give you a successful read. The confidence is a little bit lower. It's at 51, but it's able to do an analysis of this license plate regardless. Lastly, we have a license plate in foggy conditions. So you can see there's a lot of steam or fog on this ramp, this heated ramp. And really what the system is looking at is looking for the license plate and running OCR on that. So any kind of distractions from fog or from any other environmental conditions are not a problem for the system to handle. So now we're going to talk about some hardware and operational conditions that you need to think about before deploying an LPR system. So firstly, we have environmental conditions. So you have to look at, will my system or my parking lot be exposed to weather elements? You have to get appropriate equipment based on that. How much ambient lighting is in the entry and exit laneways? There's also regional and jurisdiction considerations. So, for example, some jurisdictions like Quebec and Alberta only have back license plates, so you don't really need a two camera per lane scenario there. You also want to be aware of the expected speed of the vehicle. So depending on the speed of the vehicles, you'll need to configure the parameters accordingly. And you also want to make sure that you have viable mounting points available for the cameras. So ideally, you want to pick a runway where all vehicles come into. If it's a very open lot where vehicles can come in from a number of different places and it's not controlled, then you might have some issues capturing all license plates. Next, you have some infrastructure considerations. So you want to see that where the expected mounting points will be. Do you have existing power? Do you have existing network? If not, is it possible to get network and power there? You have to take that into considerations, as well as looking into any kind of lane delineators, speed bumps, and additional ambient lighting you may need to add to help the system perform optimally. Next, you have the equipment consideration. So the cameras and the servers are important here. You want to make sure that the cameras have sufficient optical zoom. They might have capabilities such as WDR that help expose the license plate appropriately. You want to make sure the camera's resolution is sufficient, and the camera comes with a dedicated IR depending on your ambient lighting conditions. And if it does come with a dedicated IR, does it have an IR cut filter in order to analyze and capture the plates accordingly? And finally, do you have for the server side, you want to make sure that you have an environmentally controlled room that you can place a server in, so you don't run into issues with the server overheating, et cetera. The edge cases are also important, where you want to make sure that in case the license plate cannot be read, what do you want to do with that specific vehicle? Do you just ignore it? Do you have other ways to verify the credentials of that specific vehicle? You also want to make sure that if the vehicle is not on the access list and it tries to come to a staff lot, for example, how do you handle that? Do you have an intercom system to have the customer talk to a monitoring agent that's able to let them in temporarily, or other kind of operational scenarios there? You also want to make sure and identify who will be utilizing the system and who will be monitoring the system to make sure it's actually working the way you expect it. And from the enforcement side of things, if you're using a LPR system for enforcement, you want to check and make sure that the enforcement rules are defined with respect to grace periods, maximum dwell times. There's a lot of different scenarios to consider when looking at enforcement. You also have some software considerations to take into place. So, for example, does the system use advanced AI models? And has the models been trained on enough relevant regional and real world data so it'll perform optimally? You want to make sure the system is ideally camera agnostic. So some systems are locked into a specific model and type of camera, whereas other systems are more open to using different types of cameras. You might have some existing infrastructure that you might want to utilize to capture the license plates. You want to also see if the camera has available APIs to integrate with some of your existing third-party systems. And you also want to see if the system has a BI tool or dashboard available where you can view all of these events and you can use that for auditing and analysis. So finally, the good news with the AI-based LPR is today's performance will only improve in the future with better technology, increasing speed and accuracy while reducing the cost. Additional integrations and APIs will also allow for even better customer and business experience. For example, we're looking into doing some sort of anomaly detections. We're also looking to do more data-driven comprehensive dashboards that'll give business users more insights as to how their parking lots are being used. And also improvements in the computing technology and camera hardware will enable more dependability of the system. So you're sure that the system will run optimally for a long time.
Thank you, Cynthia and Jay, for all the insightful information on AI-based LPR. So before we wrap things up, we're going to have a quick Q&A. So if you have any questions, please feel free to leave them in the chat. There's a couple already, so we'll start with this one. I think, Jay, you might be able to answer this one. So it's, what is the processing time of the LPR system for a gated system? They're just looking to redevelop their lot and minimize
Yeah, I mean,
cars backing up into the road.
that's a very good question. And really, we've looked at a number of different LPR systems in the past. And currently, we are at a point where You don't even have to stop for the gate to open. As long as you're coming in at a reasonable speed, let's say 5-10 kilometers an hour, you can continue rolling. And as long as the cameras are placed optimally, it's going to capture the license plate before the induction loop is even activated and send that license plate over to the system to open the gate within 1 to 2 seconds.
So the next question is, what would be the minimal internet what would be the minimal internet bandwidth that would allow for the use of such a system?
So typically what we do is we like to put the LPR server that's doing all of the processing on premise. And we see that with the parking, with our parking infrastructure as well. This is something that we like to process and do everything on premise in case there's any specific internet issues. So really when we're looking at the required internet speeds, something reasonable like 5 Mbps download is the minimum, I would say. It depends on what you're looking to do with the system in terms of other functionalities. But locally, the cameras need to talk to the license plate server, and that's going to do all of the analysis that is required to get all of the license plate events.
Next one is, can AI be integrated into a very basic existing parking system to improve efficiency and reduce issues like non-functional meters or payment errors?
So actually, Alex, if I can, it's Cassandra's actually asked a couple questions here. And the short answer is yes. The more complicated answer is, of course, we need to understand exactly what you have, how it's working, how it's not working, before we could give recommendations on the technology enhancements that could be provided and what an estimated cost would be. And the ROI timeline for an investment, that'll be driven by a lot of factors like cost of the investment, how you're paying for it, and how much you're charging for parking. Those would be the really three big things. But Sandra, we can have someone reach out to you. I believe we have your contact information from when you registered, and they'll be able to guide you through a more detailed conversation that is aligned specifically with your parking operation.
So the next question is, how does AI LPR perform when it comes to on-street parking enforcement?
Okay, so I can speak to that as well. So what's going to happen is that you're going to have the cameras are going to be on a vehicle, or they're going to be in a patroller's cell phone or their tablet, and they're going to go by and they're going to scan the license plates. So as long as a parking session or a permit is registered to a license plate, that information will have been provided to the enforcement platform or a lookup tool. And it will, when you scan the license plate, it'll say, it's only actually going to flag if there's not a valid parking session. So if it's a valid parking session, nothing is going to come up. And if they've run out of time, or if they just don't have anything, that information will be shared. And it'll be working that way with the free parking zones as well. I'm just reviewing your question here. So if they've run out of time, if they've exceeded the rules, or if they have stayed too long in a free parking zone, the enforcement software can be programmed for all of those rules and all of those parameters. The parking technology that accepts the payment is going to send that information to somewhere where the enforcement platform can connect into, and that's how they're going to talk. And then the LPR component is going to capture those images and do what it needs to do by checking. And then the AI, where that's going to come into, is going to help making sure that we get clean captures and the optical character recognition on those license plates. And then it's going to help with some metrics and potentially with some advanced analytics and helping make business decisions about enforcement times, perhaps, or enforcement rules, or even something as basic as letting you know when somebody has parked and hasn't come in, if you can kind of segregate an area with license plate recognition. So Jovial, if you're interested, what we'll do is we'll have someone reach out to you, talk about this a little bit more. So just let us know if we've answered your questions or if you want more information.
Right. So the next question is, if an LPR system is down, what is the estimated ETA for it to be fixed? And are there any disadvantages to having an LPR system?
That would be a J question. I think it's not a me question.
Yeah, I mean, in terms of the if the LPR goes down, that's more of a SLA level discussion as to depending on the support level packages that you have with us. There's going to be variance in terms of the response time. Typically, though, we try to manage and monitor our LPR systems to make sure that if it does go down, we get notifications as soon as possible in order to make proactive decisions to get them back up as soon as possible. But usually we don't have a lot of concerns with LPR systems going down. We have a number of LPR locations already, and usually the reliability of the system is quite high, I would say. And then in terms of disadvantages of the LPR system, the only thing that I can think of is a lot of customers don't realize that it's not a 100% perfect system. So I kind of touched on that is what happens when a license plate is not able to be read. So for example, in Ontario, you see some really old license plates from 10, 20 years ago, and their paint is completely peeled off, and you can't even read the license plate with your own eyes. So in that kind of a scenario, you might want to have a backup credential system or a backup way for that person to enter a gated lot, because the no license plate system will be able to read that kind of a license plate.
And I just want to add on that this is actually really, really rare. It tends to be a network issue. So, from the internet service provider rather than a hardware issue. It's just a camera, right? So camera's going to take a picture, and so it's going to be, can that image get to the software? And that usually is put down to a network issue. And our ISPs here in Canada are usually really good at bringing those back up as quickly as possible. So downtime really is minimal.
Next question is, in cases where customers claim they paid for parking, but there is no record in the system, how can AI help resolve these disputes more effectively? Maybe Jay can answer this one.
Yeah, I mean, I'm not sure that's more of a technical question from an AI perspective than than an operational consideration. So from the AI perspective, really what we're focused on is enabling a more accurate way of detecting license plates. Once you have the actual license plate, the rest of the procedures are generally the same as it would be with a traditional LPR system. I'm not sure if that helps answer your question.
And someone is just asking if you can repeat the bandwidth number for the minimal internet bandwidth that would allow.
Yeah, I mean, off the top of my head, don't quote me on it. I mean, but depending on some of the other some of the other requirements of your site. So some sites have, video surveillance that's being transmitted over the same internet line. But we generally recommend at least 5 Mbps, or if you want to be a little bit more safe, at least 20 Mbps download and upload. That's the ideal speed that would work with our parking systems and LPR systems. But like I was saying, the LPR server and the LPR cameras are generally placed on premise. So the internet connection is not really a hard requirement when it comes to any kind of bandwidth concerns. Typically speaking, the events are stored locally on the LPR server, and whenever the bandwidth and the internet connectivity is available, they'll get sent over to our centralized database where more analysis and the dashboard is. So depends on the type of configuration you have, and we can definitely talk about that more offline if you have any specific concerns to your site.
And now I just wanted to go back to Sandra's question about how AI can help resolve disputes more effectively if a client or a parker rather claims that they paid for parking, but there's no record in the system. It's not really going to be an AI thing so much as just the images that the license plate recognition system captures. You can type it in and you can see when they entered and when they exited, and then you can calculate a parking fee due that way. And you've got the proof of those pictures that were captured. So it helps with a little bit more gentle handling of the situation is what our experience has been.
And then someone's asking what technology we use to transmit the data from the cameras to the servers.
So in terms of technology, I mean, it's just a simple IP stream, IP connection. So typically from the network side, the cameras and the servers are located in the same subnet on premise. So there's no transmission of the video stream over the internet to a cloud-based server or anything like that. I'm not sure if that helps answer your question.
So maybe a little bit less technical, an Ethernet line, a Cat6 cable, power over
Yeah,
Ethernet
that
setup.
in terms of the actual line, it's just the Ethernet connection that you need to the cameras. And from the video perspective, it's just a H.264, video stream that's processed on the server side from the camera.
So the next question is, how quick is exit process for visitors who take a ticket in a gated LPR system and pays in advance at POF or our parked in platform? Will vehicles be able to approach the gate and have gate lift without vehicle coming in to stop?
So I will take that one on. So we had that question earlier from one of our attendees. So really, it's just as fast. So anything that happens with the LPR system is going to happen within the time that it takes for an entry or an exit gate and terminal to do what it does. So it happens kind of within that. So there's no additional time required. So what's happening here is if we've paid in advance so we're going to back it up because I'm jumping ahead here. Just want to explain the scenario a little bit. We have a gated parking lot. We have an LPR camera. Someone has come in. And as soon as they approach and they cross that loop, what's going to happen is it wakes the system up. And the LPR camera is going to take a picture and the terminal is going to wake up and it is getting ready to issue a ticket. So when you wave or when you push a button, you take your ticket, and in the milliseconds or whatever, however it happens, the LPR, the license plate characters that have been extracted from the image are associated with the ticket number. And then when you go about, you do your thing, now it's time to pay. So you can pay at a pay on foot station or you can pay with the Parked In app in advance to arriving at the exit gate. So what's going to happen is now is the system is going to recognize that, oh, hey, that license plate and that ticket are paid. So when you approach the exit, again, as you're approaching, the system's going to wake up, the camera's going to take a picture of a license plate, it's going to do its magic, and it's going to say, oh, look at that. Michael's already paid, and the gate's going to open up, and you barely have to, you don't have to stop. Please slow down. But, you can just continue. It's going to be part of that frictionless offering that LPR is going to make available. And then alternatively, if we have someone with a permit, when they approach, the picture is going to take it. We're going to recognize the license plate and say, oh, look at that. Alex, she has a permit here. Let's just open the gate. And she's just going to go right in. And it's going to be the same thing when she goes right out at the exit. So we're not coming to a stop unless, of course, somebody has overstayed and we need more money from them. But usually people leave when they say they're going to leave and once they've paid. So Michael, I hope that answers your question. If not, send us another question or we can reach out and talk more about it.
So the next question is, how is LPR accuracy reading affected within one plate provinces? If it is not, why do two camera devices be needed per lane in provinces where two license plates are required?
Yeah, so what we've seen, we actually did a recent deployment in Alberta, and the accuracy is still very good. In fact, the two camera per lane deployment is really only to give assurances to maximize the accuracy. So when you're already at a 95+% accuracy rate, if you really want to hit that 99% or 99.5%, it becomes increasingly difficult to get that much more accurate with a system that's already so good. So in that case, where the jurisdiction has the availability, we recommend putting in a front end and back camera. So in case one of those plates is covered with dirt or snow or whatever other environmental factors, sometimes the other license plate is able to pick it up without any issues. So really what it comes down to is the system will work regardless of whether you do one camera per lane or 2 cameras per lane. But with the 2 cameras per lane, it'll give you a little bit more assurance that it can handle more different scenarios that are edge cases, I guess you could say.
So the next question has a little bit of build up. So it's in our area, we have an additional requirement for authorized access to the parking lots. This info is displayed on vehicle windshields when they enter. Would this software have the ability to acknowledge these passes and update if the user is compliant or not?
So I'll take this question, and without understanding the complete context, I want to say maybe. So, and I know that's not a great answer, but it sounds, Colin, like you've got a really particular use case. I would want one of our experts to actually look into this and answer this for you. I believe this could be handled with the software through the permissions and the rights that we assign to the license plate. So it might just be a different business process. I don't think it can recognize an additional sticker and say, oh, the license plate is okay and it has a sticker. Jay, can you confirm, or is that somebody else that we need to ask?
Yeah, I mean, from what Colin says, that sounds like a custom sort of a solution. We can definitely work together to see what might be possible, and depending on how big the sticker is and some other factors, we may need a separate camera to look for the stickers, depending on the angle and the environmental conditions. So really, Colin, we'll have to deep dive into get more detail as to what the requirements are and what we can do about it from a LPR and AI perspective.
Okay, so this will be our last question, and then if we didn't get to any or you have more, we will either email you or we're going to send out an email and you can reply to us there. So this question is, can the system use both hardwired cameras and Wi-Fi cameras?
Yeah, so typically we prefer hardwired cameras. We have a couple of cameras that we've deployed in a number of sites that we prefer to have. If the camera is Wi-Fi enabled, then technically we should be able to connect to it as long as the network is stable. What we like to avoid is drop frames and drop packets, because Wi-Fi systems, depending on the location, can be a little bit finicky. We've deployed it in sites where the hardware infrastructure is not, it's not possible to get, let's say, network back to the LPR server. So we use a point-to-point system. We've used that in the past, and that's been pretty successful. I've never actually worked with Wi-Fi cameras specifically, but that's definitely something that we can look into if it is a requirement for the site.
So I'd like to once again say thank you to Cynthia and Jay for taking us through everything AI-based LPR. And I'd like to thank all of you for joining us today. And please stay tuned as you'll receive an email in the coming days with the webinar recording, and we'll follow up with any unanswered questions or anyone we'd said we'd get back to with further details on AI-based LPR. Thank you guys.